Welcome my dear learners for this course on engineering graphics. In this module 2 we were discussing on orthographic projection of plane surfaces. So far we have solved 16 problems on orthographic projection of plane surfaces. Moving ahead, the problem number 17 of our discussion states that a pentagonal lamina of sides 25 mm is resting on one of its edges on HP with the corner opposite to that edge touching VP. This edge is parallel to VP and the corner which touches VP is at a height of 15 mm above HP. Draw the projection of the laminae and determine the inclination of the laminae with HP and also the distance at which the parallel edge lies from vertical plane. Come, let us solve problem number 17, where in which we have a pentagonal lamina of side 25 mm is resting on one of its edges on HP. So draw the pentagon such a way that edge comes towards your left hand side. So let me draw XY line. As I said, we are using left hand reference not to avoid confusion. If you take edge towards right side, then you should rotate the laminae clockwise to rest it on edge. If you take edge towards left side, you should rotate it counterclockwise. We are always using left hand reference and rotating the laminae counterclockwise. So therefore take edge towards left side, you have to rotate here counterclockwise and make the laminae stands on its edge. That is following the convention what we are using. Let me draw edge towards left hand side whose dimension is 25 mm drawn. Now use angles, that is 108 degrees interior or 72 degrees exterior. Let me use 108 degrees interior on either side. Mark 108 degrees and draw the edges whose dimension is known to you, which is 25 mm. 25. Here also you draw 25. Done. Now using compass we cut arcs. From here you intersect this arc, joining which you have A, B, C, D and E, and this dimension is known, which is 25 millimeters. This is VP, HP and X. Now take the projection. Taken. So this is the laminae you have. A is visible, E is invisible, B is visible, D dash, next you have C dash. Now rotate the laminae counterclockwise because it rests on edge A dash, E dash at an angle of, so he has not given the angle. Since the laminae is resting on HP, the second position should show the inclination or the details given with respect to HP itself. The details given with respect to HP is that the corner opposite to the edge touching VP. So this edge is parallel to VP and the corner which touches VP is at a height of 15 mm above HP. So he is asking us to touch this corner to VP. Before that, this corner should be at a height of 15 mm above HP. So therefore this corner C dash should be at a distance of 15 mm above HP is the details given with respect to HP. The corner is at a height of 15 mm above HP. So therefore take a reference at a height of 15 mm above HP. So let me have a line 15 mm above HP. So I have taken a reference 15 mm above HP. So I'll draw a line and taken a reference line 15 mm above HP. Now I'll rest it on the edge A dash, E dash here. A dash, E dash. Now using compass, I will intersect this. So that will give us C dash. The corner C dash at a distance of 15 mm above HP is satisfied. Also mark B dash. That is B dash, D dash. Now he is asking us to find the inclination with the HP. How much is the inclination? You check here itself. How much is the inclination? You check here itself. The inclination is turning out to be 23 degrees. The inclination is turning out to be, I am getting the answer as 23 degrees. Now take the projection and complete the sketch. So take the projection. A and E, still here we have A and E. Next we have B and D dash. It is B and D. B is still bottom and D is here, and we have C. So connect C. Done. We got A, B, C, D and E. So join them like this. Connecting A, B, C, D, E, I will get the required top view in the second position. So this completes the second position. What he says in the final position is the details given with respect to vertical plane. He says that with the corner opposite to the resting edge touches VP. The corner opposite to the resting edge, it is resting on the edge A dash, E dash. The corner opposite to the resting edge is C, C dash. So therefore C should touch VP and the resting edge should be parallel. The resting edge should be parallel. And also is asking what is that distance. Let me do that. So C should touch VP and AE should be parallel, he says. So to do that, first you measure this perpendicular bisector line. First you measure this perpendicular bisector line. I am getting it approximately 35 millimeters. So draw 35 mm line, vertical line. Drawn. This perpendicular bisector I reproduced. Done. And I will call this as C, touching VP, C. Now we know that to this line AE is, this line is perpendicular to AE and AE is 25 mm. So therefore draw 12.5, 12.5 on either side perpendicular to this line. 12.5, 12.5 on either side. 12.5, 12.5 on either side I have drawn. So I have produced it here and drawn 12.5, 12.5 on either side, and I got E and A. Clear? So I have E, A and C. Now using compass I can produce B and D. Measure B, draw an arc. From here also you draw an arc. Measure C to D, intersect this arc. Here also intersect this arc, joining which I will get the required pentagon top view in the final position. So A, B, C, D, this is what he has asked. Now take the projection and complete the drawing. Here we have A and D is here itself. A and E. C is at the top and B and D are at the middle. B and D. So take the projection, take the horizontal projection. So this is E dash, A dash, B dash, C dash, D dash. So connect them. If you connect them, you will get it as AB, C, D, E and A. So this is the required solution for the given problem. He is asking what is the distance of this parallel edge from vertical plane. So this is at a distance of 36 mm for me. This is at a distance of 36 mm from VP. So this is the complete solution for problem number 17. Moving ahead, the problem number 18 states that a pentagonal lamina of sides 25 mm is having a side both on HP and VP. The corner opposite to the side on which it rests is 15 mm above HP. Draw the top and front views of the laminae. So this problem is similar to problem number 17. Only thing is that one side is in both HP and VP means what? This AE should be here, so that will be on both HP and VP. So till second position the problem remains same. Let me do it. We have a pentagonal lamina of side 25 mm with sides both on HP and VP. The corner opposite to the side on which it rests. So it is resting on one of its side, which is nothing but the first four positions are same. So let me redraw it. Since it is resting on one of its edges, let me draw pentagon such a way that I will get edge towards my left hand side. This is VP, HP, X. Now construct the pentagon. Construct the pentagon of 25 mm sides. Draw 25 mm. Measure 72 degrees exterior angle. Measure 72 degrees exterior angle on either side, or 108 interior, and redraw the edges. That is 25 mm, which is nothing but 2.5 centimeters. Done. Now use compass and complete the pentagon. Cut an arc from both the corners and complete the required pentagon. So this is the required pentagon, right? That is A, B, C, D and E. The dimension of the pentagon is given as 25 millimeters. Now take the projection. Take the projection. And draw the front view. This is A dash, E dash. This is B dash, D dash, and we have C dash. The corner opposite to the edge on which it rests is at a distance of 15 mm above HP, he says. So therefore measure 15 mm above HP. Let me fix the resting edge as A dash, E dash using compass. Let me transfer it. From here you cut an arc and transfer, and also you mark B dash D dash. This is C dash. Angle is already measured. I am getting it as 23 degrees. Take vertical and horizontal projection and complete the sketch. B, and finally we have C. So that is A, B, C, D and E. Done. Now the final position differs. What he says is that one of the sides is both on HP and VP. That side is nothing but the resting side. So therefore rest this side on HP and VP, that is this dimension is known, which is nothing but 25 mm. So draw 25 mm line, mark the center 12.5 12.5 on either side, and you know this length, project that length here and mark C, project length and mark C. C is also determined. C is here, I got C, and this is A and E, which is nothing but A dash E dash. Now since we know all the points, using compass you find out B and D, that is from E, cut an arc. From A you draw another arc. Now from C you measure B, intersect these two arcs. Now if you connect, you will get so this is B and this is D. Now if you take the projection, you can observe that one of the side is in both HP and VP. So take the projection, you can see that this itself is A dash E dash, that line itself is AE. So this is B, C, D. So we have the pentagon coming like this. So this side is in both VP and HP, that is nothing but A dash E dash. That line itself is AE, that is what he says, having a side both on HP and VP. So this is the complete solution for problem number 17 and 18. That's all from this lecture. Thank you all.